Scientists have long been curious about what is going on in our atmosphere and what type of effects human actions may have on it. As levels of carbon dioxide and other greenhouse gases unquestionably rise, this matter has become even more urgent. The scientists at the National Oceanic and Atmospheric Administration in Boulder, Colorado, have been working on documenting the evolution of greenhouse gases in the global atmosphere. Each day, air samples from all over the world are brought to labs in Boulder and analyzed for an array of trace gases. Altogether, these trace gases make up less than 1% of the atmosphere, but they are crucially important for the Earth's climate and play a significant role in air pollution. At the same time that these measurements are being taken, similar measurements are being taken continuously throughout the day at remote observatories and tall tower sites across the United States. The resulting data provide a great deal of information to scientists, as well as the general public, as to what is happening in our atmosphere. NOAA's Global Monitoring Division, located in Boulder, Colorado, is the command center for the various atmospheric measurement programs that it runs throughout the world, and all samples and data eventually make their way back to this location. NOAA senior scientist Peter
These measurements were actually started before we started. They were started by David Keeler of Scripps in 1958 on the NOAA volcano in Hawaii. So now we have an actual direct measurement record since 1958.
In addition to keeping a direct measurement record since 1958, NOAA has also expanded its measurement programs to about 20,000 samples per year from a global network of surface sampling sites, tall towers, observatories, and small aircraft. As part of the surface sampling network, the Global Monitoring Division sends over 6,000 flasks to around 60 different locations across the globe. Flasks travel as far away as the Gobi Desert, New Zealand, and the South Pole. Some are even sent out on ships to collect samples in the middle of the ocean. Samples are mostly collected in remote locations, far from local sources of pollution, in order to measure the planet's background air, which provides a good representation of the planet's atmosphere because it has been unaffected by local sources of pollution. At these 60 different locations, trained volunteers and scientists collect 2 flask samples simultaneously once every week using a case with a battery-powered pump. The 2 flasks are placed in the case and hooked up to a single air intake tube. The opposite end of the air intake tube runs up a long pole that telescopes up out of the case in order to gather a more pure air sample. Samples can be taken with 2 flicks of a switch. One flick flushes the glass flask of the synthetic air with which they are filled in a lab. The synthetic air mixture has known concentrations of certain gases, which are quite different from regular air, and can therefore provide a check on the sampling procedure. If, during analysis, concentrations of gases in the flask are found to be similar to the synthetic air mixture, then it can be concluded that something went wrong during the sampling procedure. Another flick of the switch allows the air sample to be collected. The whole process takes less than 10 minutes. Sample takers are also required to fill out and send back a sheet with information about the sampling, such as the time, temperature, weather conditions, and any other information that they believe might be relevant. This sheet later provides a great deal of vital information for the scientists who work with the data that results from these flask samples. In addition to the 60 sampling sites, where pairs of flasks are filled on a weekly basis, NOAA also operates 6 baseline observatories and 8 tall tower sites. The 6 baseline observatories are located in fairly remote locations: Barrow, Alaska, American Samoa, Summit Station on the Greenland ice cap, Trinidad Head off the California coast, on top of the Mauna Loa volcano in Hawaii, and at the South Pole. At these locations, on-site measurements are taken and recorded at regular time periods throughout the day. These measurements allow scientists to observe short-term as well as long-term variations in the mixing ratios of various greenhouse gases. Similar on-site continuous measurements are also collected at many tall tower sites. These sites are located throughout the United States in places like West Branch, Iowa, Walnut Grove, California, Park Falls, Wisconsin, and Erie, Colorado. Most of these tall tower sites are television, radio, or cell phone towers, whose owners have allowed NOAA to add instruments that will not only measure carbon dioxide and carbon monoxide continuously, but will also automatically take daily flash samples. flash samples are analyzed for more than 40 different gases that can help scientists understand upwind influences affecting each sample. For example, ratios of certain gases provide clues about whether agricultural, natural vegetation, or industrial areas exist upstream from the sampling site. About once a week, someone must go to each of these tall tower sites and exchange the flasks, which are contained inside a suitcase called a PFP, or a programmable flask package. Each PFP holds 12 flasks, which allow for easy shipping and measurement of the samples. In addition to exchanging the PFPs, whoever goes to the site must also run checks in the whole system. Having both the continuous measurements and the flash samples at these sites is very valuable. If both of the two flash samples collected at a given time match each other, as well as an on-site measurement that was taken at nearly the same time, scientists can then be better assured that both systems are working properly. NOAA sampling efforts reach even further into the sky aboard aircraft that fly over North America. These aircraft allow scientists to collect samples up to 8 kilometers or 5 miles above the Earth's surface. The aircraft are set up by NOAA scientists to fill flash samples at different pre-planned altitudes. At each of these altitudes, an automated system sends the pilot a message to trigger a switch, which begins the sampling process. At the end of each flight, the flasks are unloaded and sent like all of the other air flash samples to labs in Boulder, Colorado for analysis.